You think you understand energy. You pay for it. You feel depleted of it. You know machines need it. Bodies require it. The sun provides it. Energy flows from coal to fire to warmth. Energy transforms from motion to heat to light. Energy courses through the veins of the universe like blood through a living body. You are mistaken. Not in the way of one who has miscounted, but in the manner of one who searches the heavens for the crystal spheres that were never there. The error runs deeper than calculation. It touches the very nature of what exists and what we merely reckon. Consider, have you ever seen energy? Not its effects, not the spinning wheel, the rising heat, the falling stone, but energy itself. Search your memory. Search the annals of natural philosophy. You will find no instrument that detects energy directly, while no eye perceives it, no hand grasps it. What do we actually observe? Velocities, heights, temperatures, masses. We watch a stone fall and measure how fast it moves. We note how high it began. We feel how warm the ground becomes when stone meets earth. These are phenomena, the actual behavior of actual matter in actual motion. Then we calculate. We take the mass and multiply it by the square of velocity, halve the result, and call this number kinetic energy. We take the mass and multiply it by height and gravitational pull, and call this number potential energy. The numbers exist in our ledger. The stone exists in the world. And here lies the great misconception. We mistake the calculation for the thing calculated. It is manifest that the error operates through language itself. When we say energy flows or transforms, we employ the grammar of physical objects. Water flows, metal transforms. These are things doing things. But energy is a number we compute. Numbers do not flow. Numbers do not transform. We recalculate, and a different number appears in a different column of our ledger. Watch a pendulum swing. At the peak of its arc, it pauses, motionless for an instant. At the bottom, it moves fastest. We say potential energy becomes kinetic energy. But attend carefully to what you actually witness. A mass moving through space, accelerating and decelerating under gravitational influence. At the peak, velocity is zero. At the bottom, velocity is maximum. These are the phenomena. The transformation occurs only in our categories, not in the pendulum itself. Our no-glowing substance drains from an invisible reservoir above and fills another below. No fluid travels from potential container to kinetic container. The mass swings. Our numbers change. That is all. Now consider a thought experiment. Imagine you possessed a sense that could perceive energy directly, as you perceive colour or sound. What would you see when a ball rolls downhill? Would a luminous substance visibly drain from the hilltop and flow into the moving ball? Where would this substance reside? In the ball itself, in the space around it, in some invisible container attached to its position? The absurdity of the image reveals the absurdity of the assumption. You might object, but surely energy is real. I pay for it, I consume it, my body needs it. Attend more carefully. When you pay for energy, you pay for fuel, coal, wood, oil, or for the labour of those who arrange for your convenience. The fuel burns, atoms reconfigure, heat emerges. You pay for matter and arrangement, not for cosmic substance. When you feel depleted of energy, you experience specific conditions. Muscles ache, attention wanders, hunger gnaws. These are not the absence of some invisible fluid. They are particular states of your body, states with particular remedies. Sleep for the tired, food for the hungry, rest for the strained. Notice how the metaphor of energy as substance obscures rather than illuminates. The exhausted man who thinks, "I need more energy," may reach for stimulants, seeking to somehow replenish his imaginary reservoir. The exhausted man who thinks, "My muscles are fatigued and I have not eaten," knows precisely what he requires. The first grasps at vapour. The second addresses actual conditions. The deepest error is assuming that because our calculations work, they must track a real substance. But useful fictions need not be literal truths. Consider the number 0. It revolutionized arithmetic. Without it, mathematics as we know it could not exist. Yet 0 points to no object in the world. You cannot show me 0 apples. You cannot weigh 0 stones. Energy may be similar, indispensable to calculation, invisible to observation, pointing to nothing in the world. This is not a diminishment. This is clarity. Before we can build understanding on true foundations, we must clear the rubble of false assumptions. You have never seen energy. You have only calculated it from observations of other things: velocity, mass, height, temperature. The confidence you felt was unfounded. The phantom substance dissolves under careful examination. But if energy is not a substance we observe, why do our calculations balance so precisely? When we calculate energy before and after any process, why do the numbers match with such uncanny accuracy? Something must explain this, and the answer lies not in what energy is, but in how we have constructed the very concept. Here is a marvel that demands explanation. Our energy calculations never fail. Drop a stone from any height, measure its velocity at the bottom, calculate kinetic energy gained and potential energy lost. The numbers match. Every time, without exception. Throughout all recorded experiments in natural philosophy, the energy ledger has never shown a discrepancy that could not be accounted for by careful measurement. Why? The common answer is this: energy is a cosmic substance that cannot be created or destroyed, only transformed. Like water that cycles from sea to cloud to rain, to river to sea again, energy cycles through its forms: potential, kinetic, thermal, but the total amount never changes. Conservation, we are told, is a discovered fact about nature's inventory. But this is precisely backwards. Consider a merchant who tracks his wealth in gold and silver. He uses fixed exchange rates. 1 ounce of gold equals 20 ounces of silver. No matter how often he converts between currencies, his total recorded wealth stays constant. Gold to silver, silver to gold. The ledger always balances. Is this because some cosmic substance called wealth is being conserved? No. The ledger balances because the exchange rates are consistent. The constancy follows from the merchant's definitions, not from nature's inventory. Now, consider energy. We define kinetic energy as half the mass multiplied by velocity squared. We define potential energy as mass multiplied by height multiplied by gravitational attraction. These definitions were not arbitrary discoveries. They were carefully constructed so that their sum would remain constant under the laws of motion. The ledger balances because we built it to balance. Let me be more precise. The laws of nature do not change with time. The gravitational attraction that governs a falling stone today governed it yesterday and shall govern it tomorrow. The rules by which masses accelerate under force are the same rules that applied when the earth was young and will apply when it is old. This temporal uniformity, this constancy of nature's operations, is itself a profound and remarkable fact. It need not be so. One can imagine universes where gravity's strength varied from day to day, where the laws of motion shifted without warning. Such universes would be chaotic, unpredictable, perhaps uninhabitable, but our universe is not such a place. And from this constancy, mathematics demands conserved quantities. When the rules do not change with time, something in our calculations must stay constant as well. This is not speculation, but demonstration. It follows necessarily from the mathematics of motion under unchanging law. We call that constant energy. Whence it follows that we did not discover energy, and then notice it was conserved. We defined energy as that which is conserved when laws stay constant. The conservation is built into the definition, and derived from the symmetry of nature's operations through time. The laws of motion are primary. Energy conservation is derivative. We have been reading the relationship backwards for so long that the reversal feels strange. But consider, which did we know first? We observed stones falling, planets orbiting, pendulums swinging, the phenomena of motion under force. From these observations, we deduced the laws of motion. And then, recognizing that these laws did not change with time, we constructed a bookkeeping system, energy, whose invariance was guaranteed by that constancy. The ledger balances because we designed it to match what nature guarantees. This understanding has practical consequences. Notice how we speak of renewable energy, as though nature manufactured a substance we might harvest, and/or energy crisis, as though some cosmic reservoir were draining. These phrases reveal the substantialist assumption embedded in common speech. The phenomena are real. Wind truly blows. The sun truly shines. Fuel truly burns. But energy is our way of keeping accounts, not a thing being moved from place to place. Here is an exercise that will sharpen your perception. Next time you encounter energy transformation, water falling over a mill wheel, a pendulum swinging, a fire burning, attend not to the supposed energy, but to the actual phenomena. What moves? What accelerates? What changes configuration? Describe the process without using the word energy. You will find you can describe everything that happens in terms of force, motion, and matter. The water falls because gravity pulls it downward. The wheel turns because falling water pushes its paddles. The mill grinds because the turning wheel transmits force to the stone. At no point does energy enter the description, except as a convenient summary of what forces accomplish. Energy was never necessary to the description, only convenient for calculation. Do not conclude from this that energy is arbitrary or useless. The accounting works brilliantly. That is precisely its value. The architect who calculates whether a waterfall can power his mill uses energy analysis to remarkable effect. The natural philosopher who predicts whether a certain motion is possible consults the energy ledger with confidence. But usefulness and substance are not the same thing. A map of London is remarkably useful. The streets on the map correspond to real streets. The intersections occur where the map says they do. A traveller who follows the map finds his way. But no one imagines the map is London. The map represents London. The representation is useful because it accurately captures patterns in reality. Energy is the same. Our energy calculations succeed because they accurately track patterns in how matter behaves under unchanging law. The tracking is useful. The tracking is precise. The tracking is not the substance it tracks. The ledger is not the gold. Before, you believed energy was conserved because some cosmic substance cannot be created or destroyed. After, you understand that energy is conserved because we defined it as what remains constant when nature's laws stay uniform. Conservation is mathematical consequence, not physical discovery. But a question presses forward. If we set aside the phantom substance, if we cease imagining energy as a fluid flowing between invisible containers, What remains? What actually happens when phenomena proceed? We have dismantled the false understanding. Now, we must construct the true one, and that requires examining, with the precision of natural philosophy, what actually occurs when stones fall, springs release, and fires burn. When we strip away the energy metaphor, we see the world more clearly, not less. This may seem paradoxical. We have removed a concept used everywhere, in philosophy, in engineering, in daily speech. What remains when the phantom substance dissolves? What remains is reality. A falling stone accelerates according to gravitational force. This is what happens. The force acts upon the mass, producing acceleration. The stone moves faster as it falls, not because potential energy converts to kinetic energy, but because a force is impressed upon it continuously, changing its state of motion moment by moment. This is the actual machinery of nature, forces acting upon masses. Particles collide, exchanging momentum. When the falling stone strikes the earth, its particles, which were all moving together downward, encounter the earth's particles, which are relatively still. The collision redistributes motion. Some of the stone's particles rebound, some of the earth's particles begin moving. The complex exchange follows laws of force and momentum. This is what happens. Chemical bonds break and form, releasing constrained motion as heat. When wood burns, atoms bound tightly in complex structures break free and recombine with oxygen in the air. The new arrangements, carbon dioxide, like water vapor, are more stable, requiring less force to maintain. The excess motion that had been constrained in the tight bonds now spreads outward as the random motion of particles, which we feel as heat and see as flame. This is what happens. In every case of supposed energy transformation, we can trace the actual mechanical process without invoking energy at all. Forces act upon masses, configurations change, motions redistribute. Energy summarizes these processes. It does not cause them. It is manifest that the error most make is imagining energy as an active participant. Energy causes motion. Energy does work, but energy is a number we calculate. Numbers cause nothing. Numbers do nothing. Forces cause accelerations. Collisions transfer momenta. Configurations constrain and release motion. Our energy is our accounting of what happens. It is not a participant in the happening. Let us examine this more carefully with an example everyone knows. The compressed spring. We say a compressed spring stores energy. But what is actually stored? Consider the spring in its relaxed state. The metal coils maintain certain distances from each other, their natural configuration, where internal forces balance and no net force pushes outward. Now, compress the spring. You force the coils closer together than their equilibrium. The metal resists. The coils push back against your hand. You have created a configuration where internal forces are not balanced, where the metal actively pushes against whatever constrains it. What is stored? Not energy as substance. What is stored is a configuration, an arrangement, where forces are poised to act, and or release the constraint, and the forces act. The spring expands. Anything attached to the spring accelerates as those forces push against it. The stored energy was always stored arrangement, stored forces, stored potential for motion. The spring's configuration guaranteed that forces would act when released. Nothing more mysterious than this. Nothing more substantial than arrangement and force. Consider another example, the elevated stone. We say it contains potential energy, but examine this carefully. The stone sits on a ledge, at rest. Where is this potential energy located? In the stone? Around the stone? In the space between stone and ground. Here is the revealing question. Change the reference frame. Dig a pit beneath the stone. The stone has not moved. It sits on the same ledge in the same place. Yet its potential energy relative to the pit floor has increased. If potential energy were a substance contained in the stone, how could digging below it increase what the stone contains? The answer is plain. The stone contains nothing. Potential energy is not a property of the stone, but a calculation about the stone's relationship to other things, the ground beneath it, the gravitational attraction between them, and what would happen if the stone were released. Potential energy is prediction dressed in the language of substance. An elevated stone has potential energy only in the sense that if it falls, then we can predict what motions will result. The potential is in our prediction, not in some container attached to the stone. The stone merely sits there, acted upon by gravity, supported by the ledge. Release it. We and gravity will accelerate it downward. This is configuration and consequence, not storage and release of cosmic fluid, from which it appears that what we call stored energy is always stored configuration. A chemical gradient, arrangements of atoms poised for reaction. A mechanical stress, arrangements of matter where forces are unbalanced. An elevated position, arrangements where gravitational force will cause acceleration if constraints are removed. Describe the configuration, and you have described what exists. Calculate the energy, and you have summarized what will happen. This understanding liberates rather than diminishes. The natural philosopher who grasps this sees more clearly into nature's actual operations. When presented with a device said to store energy, he asks, what configuration maintains this storage? What forces constrain this arrangement? What will happen when constraints are removed? These questions lead to mechanical understanding. The vague notion of energy storage leads only to further vague notions. Here is an exercise for sharpening perception. Examine any device said to store energy, a raised weight, a wound clock spring, a drawn bow. Describe precisely what is stored. You will find in every case it is a configuration, a position, a stress, an arrangement. Then describe what happens upon release. You will find that forces act, masses accelerate, configurations change. At no point does energy do anything. Forces do everything. The wound clock spring illustrates this beautifully. Winding it creates torsional stress in the metal. The coils twisted from their equilibrium. Internal forces pushing to unwind. The escapement mechanism releases this stress gradually, allowing the spring to unwind in controlled increments. Each increment of unwinding allows the spring's forces to act on the gear train, which transmits motion to the hands of the clock. Every step is force and motion. Energy enters only when we summarize. The potential energy stored in the spring converts to kinetic energy of the hands. But this summary, however convenient, describes no actual event. The actual events are torsion, force, acceleration, motion. The conversion is our recategorization of the same underlying reality. Before, energy transforms from form to form, causing things to happen. After, forces act upon masses. Configurations change. Motions redistribute. Energy is how we keep track, not how things work. As we can now describe phenomena without invoking phantom substances. But questions remain. Why does potential energy depend on an arbitrary baseline? How do we account for heat, which emerges when motion becomes disordered? The mechanics require deeper examination. Here is an oddity about potential energy that reveals its true nature. It has no absolute value. Choose any height as your 0 point. The floor, the ground, sea level, the center of the Earth, and the potential energy of every object in the universe changes accordingly. Set your baseline at ground level, and a stone on a table has positive potential energy. Set your baseline at the tabletop, and the same stone has zero potential energy. Set your baseline at the ceiling, and the stone has negative potential energy. Yet the stone has not moved. The stone sits in the same place, arm subject to the same forces, behaving in exactly the same way. Only your choice of baseline has changed. How can this be if potential energy is a substance stored in the object? The answer is plain. It cannot be. Potential energy is not stored in objects. It is calculated relative to arbitrary reference points. What changes with arbitrary choice cannot be substance. Substance does not depend on where you decide to put your zero. It is manifest that only differences in potential energy have physical meaning. The stone falls from table to floor. The difference in height multiplied by mass and gravitational attraction gives the change in potential energy. And this change is the same regardless of where you set your baseline. The change corresponds to the actual motion of the actual stone under the actual force of gravity. But the absolutes are arbitrary. The differences are invariant, and the differences are all that matter physically. Consider two identical stones resting on identical ledges. One ledge overlooks a deep valley, the other overlooks a high mountain plateau. Relative to the ground immediately beneath each, both stones have the same potential energy. Mass times height times gravity, with height being the distance to the ground below. But relative to sea level, the stone above the valley has far more potential energy than the stone above the plateau. The valley floor is lower, the height to sea level is greater, the calculated energy is larger. Yet the stones are identical. Their situations are identical in every respect that matters. Same mass, same local height, same gravitational pull, same behavior if released. Or if potential energy were a property of the stones, a substance they contained, how could one contain more than the other when nothing differs between them? The resolution is simple. Potential energy is not a property of objects, but a feature of our calculation. It describes the relationship between an object's position and what would happen if that position changed. It is a prediction, not a possession. This thought experiment makes the point vivid. Imagine digging a pit beneath an elevated stone. The stone sits unmoved on its ledge. Same place, same configuration, same everything. Yet its potential energy relative to the pit floor has increased. You added potential energy to the stone by digging a hole it has no connection to. If this seems absurd, that is because it is absurd. Absurd to imagine potential energy as stored substance. What the stone contains nothing more after you dug the pit than it contained before. What changed is your calculation, not the stone. Whence it follows that the language of storing potential energy misleads. Nothing is stored in the elevated stone. What exists is a configuration: stone above ground, gravitational attraction downward, ledge providing support, and a predictable consequence if the configuration changes. The storage is in our prediction, not in the stone. This understanding has practical implications. When engineers calculate a building's structural loads, they choose convenient reference points, usually the foundation or ground level. The choice is arbitrary. The physics is invariant. No engineer imagines the building contains more gravitational potential energy because someone chose to measure from sea level rather than street level. The calculations work the same way regardless. Yet in everyday speech, and even in casual scientific discourse, we treat potential energy as though it were a substance residing in elevated objects. We say, the water behind the dam has tremendous potential energy, as though the reservoir were filled with an invisible fluid called potential energy that would drain out when the gates opened. But the water is simply water. Its elevation above the turbines below means that gravity will accelerate it through a large distance if released. The turbines will extract motion from that acceleration. The potential energy is our prediction of how much motion can be extracted, a calculation that depends on where we place our baseline, not a substance waiting in the water. The same principle applies to all forms of potential energy. A compressed spring stores elastic potential energy, but the storage is an arrangement of matter under stress, and the energy is our prediction of what will happen when the stress is released. A chemical system stores chemical potential energy, but the storage is a configuration of atoms that will reconfigure if triggered, and the energy is our prediction of how much motion will emerge. In every case, the potential is in the prediction, not in the object. Configuration, not container. Relationship, not residence. Before, an elevated object contains potential energy, like water in a tank. After, potential energy is calculated relative to arbitrary baselines. Here the only difference is matter physically. The object contains no substance, only configuration. But what of kinetic energy, the energy of motion? Here surely is something more tangible. The moving object visibly moves. The motion is not relative to arbitrary choice, or is it? And what of heat, which emerges when motion becomes disordered? These phenomena demand examination. When a hammer strikes an anvil, warmth emerges. When you rub your hands together, they heat. When a falling stone hits the ground, the impact site becomes warmer than before. We are told this is kinetic energy transforming into thermal energy. Motion becomes heat. One form of energy converts to another, but attend carefully to what actually occurs. Before the hammer strikes, the hammer moves as a unified mass. All its countless particles share a common velocity, are all moving together, downward, toward the anvil. This organized collective motion is what we call the hammer's kinetic energy. Half the mass times the square of velocity. After the hammer strikes, the hammer has stopped, but it and the anvil are warmer. What happened to the motion? It did not vanish. It dispersed. The hammer's particles, which were all moving together, collided with the anvil's particles. That collision scattered their motions into countless different directions. Some particles now move left, some move right, some up, some down. No common pattern remains. The collective organized motion has become individual, random motion. We call this random motion heat. This is not a transformation of substance. This is redistribution of motion. It's what was ordered, all particles moving together, became disordered. Particles moving independently in all directions. Our bookkeeping calls this kinetic energy transformed to thermal energy. But the underlying reality is simpler. Motion changed from organized to random. The nature of heat, properly understood, is disordered particle motion. When you feel warmth, you feel countless tiny impacts, particles moving randomly, colliding with your skin, transmitting their motion to your flesh. Heat is not a fluid that flows. Heat is not a substance that transfers. Heat is motion without organization, vibration without direction, agitation without pattern. The old error, imagining heat as an invisible fluid called caloric, that flowed from hot bodies to cold, was definitively abandoned. Or no one any longer believes that fire adds caloric fluid to water, or that ice draws caloric away. We recognize that heating means increasing particle motion. Cooling means decreasing it. Yet the energy concept inherits similar confusion. We speak of heat energy flowing from hot objects to cold ones, as though something substantial moved between them. We say thermal energy transfers through conduction, as though a fluid passed from particle to particle. The reality is simpler and stranger. Consider what happens when a hot iron touches a cold stone. The iron's particles are vibrating rapidly, moving in random directions with high average speed. The stone's particles are vibrating slowly, moving in random directions with low average speed. Where they touch, collisions occur. Fast-moving iron particles collide with slow-moving stone particles. On average, the fast particles slow down. The slow particles speed up. Motion redistributes from more agitated to less agitated, from faster vibration to slower vibration, until both materials reach the same average particle speed, the same temperature. Nothing flowed except motion itself. Nothing transferred except the pattern of vibration. The iron cooled and the stone warmed, not because a fluid moved between them, but because collisions averaged out differences in agitation. Why do our energy calculations balance through this process? Because total motion, properly quantified, is conserved through collisions. When particles collide, momentum exchanges, kinetic energy redistributes, but the total, calculated according to our definitions, remains constant. The conservation follows from the mechanics of collision, not from the persistence of some special substance. This understanding illuminates why heat flows in one direction. Ordered motion naturally becomes disordered. Friction scrambles organization. Impact scatters collective motion into random individual motion. But disordered motion rarely spontaneously orders itself. You never see a cup of warm tea concentrate all its heat into one corner, leaving the rest cold, because random particle motions almost never accidentally align into collective motion. This asymmetry is probability, not substance. Random motions rarely happen to coordinate. Coordinated motions easily become random. The direction of change reflects the overwhelming improbability of disorder becoming order, not the nature of a flowing fluid. But here is a practical observation that makes this vivid. Rub your hands together vigorously. They warm. What happened? The ordered motion of your arms, muscles contracting in coordinated patterns, limbs moving in deliberate strokes, became disordered motion of surface particles through friction. Skin scraped against skin. The collective motion of your rubbing became the random motion of agitated surface molecules. You feel this as warmth. No substance flowed from your arms to your palms. Motion redistributed from organized to random. Work became heat. This is the ancient discovery, verified countless times. Mechanical motion converts to thermal motion through friction, impact, and resistance. But conversion means redistribution of motion, not transfer of substance. The same principle illuminates fire. When wood burns, what happens? Are the atoms bound in wood, carbon, hydrogen, oxygen in complex arrangements, break free and recombine with atmospheric oxygen? The new arrangements, carbon dioxide, water vapor, are more stable, less constrained. The motion that was locked in tight bonds spreads outward as random particle motion, flame and heat. Nothing called energy escapes the burning wood. Atoms reconfigure and motion redistributes according to laws of force and collision. We calculate chemical energy released by measuring the heat produced and accounting for the molecular rearrangement. But the calculation tracks what happened. It does not add a substance to the happening. Before, heat energy flows from hot objects to cold ones. Energy is transferred and transformed. After, motion redistributes from ordered to disordered, from faster particles to slower particles. Or nothing flows except the understanding. We have traced what actually happens in falling stones, compressed springs, burning fires, conducted heat. The phenomena become clearer when freed from phantom substances. But one question presses: if energy is accounting and conservation is definition, why does this accounting prove so magnificently useful? There must be something it tracks, even if not a substance. There must be a reason the ledger balances with such remarkable precision. The answer lies in what we have already glimpsed: the constancy of natural law through time. But this principle deserves fuller examination, for it reveals something profound about our universe and about our capacity to understand it. We have dismantled the phantom substance. We have traced what actually happens when stones fall, springs release, fires burn, and heat conducts. We have seen that energy is accounting, not substance, calculation, not cosmic fluid. But a question remains, and it is the deepest question of all. Why does the accounting work so magnificently well? If energy were arbitrary bookkeeping, mere convention, with no connection to nature's actual operations, we would expect the ledger to drift. We would expect discrepancies to accumulate. We would find situations where the numbers failed to balance, where energy appeared from nowhere or vanished into nothing. Yet this never happens. Every serious experiment in the history of natural philosophy confirms the conservation of energy. Every failed perpetual motion machine fails in exactly the way energy analysis predicts. Every calculation of what is possible and what is impossible proves correct when tested against reality. Why? And the answer lies in a profound fact about our universe, a fact so fundamental that we often fail to notice it at all. The laws of nature do not change with time. The gravitational attraction that governs a falling stone today is the same attraction that governed it yesterday. The same force that pulls the apple from its branch today pulled apples from branches 1,000 years ago, and will pull them 1,000 years hence. The rules of motion, the principles of collision, the mechanics of force and mass all remain constant through time. This temporal uniformity is remarkable. It need not be so. One can imagine a universe where gravity's strength varied from day to day, strong in the morning, weak at night. One can imagine laws of motion that shifted without warning, where yesterday's physics offered no guidance for today's phenomena. And such a universe would be chaotic, unpredictable, perhaps unlivable. Certainly it would be incomprehensible. But our universe is not such a place. And from this constancy, this symmetry of nature through time, mathematics demands conserved quantities. Let me explain this more carefully. When the rules that govern a system do not change with time, the mathematics of motion entails that something must stay constant through all the system's transformations. This is not speculation or approximation. It is demonstration. Given temporal symmetry, conservation follows by necessity. We call the conserved quantity energy. Whence it follows that we did not discover energy as a substance and then marvel that it was conserved. We defined energy as the quantity whose conservation is guaranteed by temporal symmetry. The conservation is built into the definition, derived from the symmetry of nature's operations through time. The laws of motion are primary. Energy conservation is derivative. Consider an analogy that illuminates this relationship. A merchant trades in gold, silver, and copper, using exchange rates that never change. 1 ounce of gold equals 20 ounces of silver. 1 ounce of silver equals 50 ounces of copper. These rates are fixed, permanent, unvarying. No matter how the merchant converts among his currencies, gold to silver, silver to copper, copper back to gold, through any sequence of trades, his total recorded wealth stays constant. This constancy is not accidental. It is not because some special substance called wealth persists through transformations. It follows necessarily from the fixed exchange rates. Change the rates, and the total would drift. Keep the rates constant, and the total must remain constant. The conservation of recorded wealth follows from the stability of the rates. Now substitute nature for the merchant. Nature's exchange rates are the laws of force and motion, the rules by which mass converts to acceleration, velocity converts to position, force converts to momentum. These rates do not vary with time. Therefore, something in our calculations must stay constant through all transformations. We call that constant energy. The merchant's total wealth follows from fixed exchange rates. Our energy conservation follows from fixed natural law. Both are mathematical necessities, not mysterious substances. This understanding resolves the puzzle we began with. The accounting works so well because it was constructed to track what temporal symmetry guarantees. We built the ledger to match what nature's constancy ensures. The precision of energy calculations reflects the stability of natural law, a stability so thorough that our mathematics captures it perfectly. It is manifest that this stability is itself a fact-demanding wonder, that the rules governing phenomena today match those of yesterday and tomorrow. This uniformity is not logically necessary. It is an empirical fact about our particular universe. Other universes might lack it. Ours does not. Every experiment confirms this stability. We drop stones and measure their fall. Results match observations from centuries past. We calculate planetary positions using the same laws that serve ancient astronomers. Our predictions accord with measurements. We design machines using principles established by our predecessors. The machines work as designed because the principles remain valid. The uniformity of nature through time is the foundation upon which energy accounting rests, and this uniformity is the gift that makes natural philosophy possible at all. Consider what it would mean if the laws changed. Every experiment would require re-verification. Every calculation would require re-derivation. No knowledge would accumulate, because yesterday's discoveries would not apply to today's phenomena. Science as we know it could not exist, but the laws do not change, and therefore conserved quantities exist, and therefore energy accounting works, and therefore we can predict, calculate, design, and understand. And notice that every failed perpetual motion machine fails for specific mechanical reasons. Friction dissipates ordered motion into heat. Air resistance slows moving parts. Incomplete conversions leave some motion unavailable for useful work. The energy analysis predicts failure, but what actually happens is that forces dissipate motion. Configurations reach equilibrium. Ordered motion becomes disordered. The accounting summarizes the mechanical facts. It does not replace them. It does not add to them. It tracks them with perfect fidelity because it was designed to track what unchanging law guarantees. Do not imagine that temporal symmetry is trivially true or obvious. It is neither. In a universe where gravity's strength varied from moment to moment, no conserved energy could be defined. That our universe permits energy, accounting tells us something profound about its structure, that its laws are stable across time. This is not a statement about energy. This is a statement about the cosmos. Before, energy is conserved because some fundamental substance cannot vanish. After, energy is conserved because nature's laws do not change with time, and this constancy mathematically entails conserved quantities. The conservation is a consequence of symmetry, the most profound and beautiful principle underlying our ability to understand the world at all. We grasp now why the accounting works. Temporal symmetry yields conserved quantities, and energy is such a quantity. The ledger balances because it was built to track what unchanging law ensures. But what does this clarified understanding change? How does seeing energy as accounting, rather than substance, alter daily perception and practical action? Those who mistake the map for the territory act on illusions. Those who understand the map as representation act on reality. We have established that energy is accounting, not substance. Conservation follows from temporal symmetry, not from the persistence of cosmic fluid. The ledger tracks what forces and configurations accomplish. It does not add an invisible participant to their dance. But does this understanding matter practically? Can philosophy that concerns the nature of energy affect how we live and act? It can, and it does. Consider the common experience of fatigue. You wake exhausted. The day stretches before you like an impassable mountain. You think, I have no energy today. What does this thought mean? But if you believe energy is a substance, then no energy means your reservoir is empty. You need to refill it. You reach for stimulants, perhaps a strong cup of something warming, hoping to somehow pour energy back into your depleted container. But if you understand that energy is a summary rather than a substance, you ask different questions. What specific conditions have deteriorated? Why do I feel this way? Perhaps your muscles ache from yesterday's exertion. The remedy is rest, not stimulation. Perhaps you slept poorly. The remedy is better sleep, not a temporary mask. Perhaps you are hungry. The remedy is nourishment, not caffeine. Perhaps your attention is scattered by worry. The remedy is addressing the worry or finding distraction from it, not whipping your body to perform despite inner turmoil. Each specific condition has a specific remedy. The man who thinks, I need more energy, grasps at vapor. The man who thinks, I am hungry, tired, and worried, knows exactly what he needs. This is the practical yield of philosophical precision. Clear thinking produces clear action. Confused thinking produces confused action. The same principle applies to what we call energy in relationships. She gives me energy. He drains my energy. We speak as though vitality were a fluid that flowed between persons, filling us from inspiring friends and draining toward exhausting ones. But attend to what actually occurs. When another's presence invigorates you, specific processes unfold. Attention engages. The mind focuses on something interesting rather than ruminating on troubles. Interest stimulates the body's reward systems and the same pleasure that accompanies good food or beautiful sights. Anxiety decreases in the presence of trusted friends, vigilance relaxes, and the body's defensive tension eases. These are real phenomena. But energy transfer is not among them. When another's presence exhausts you, different processes occur. Vigilance increases. You watch your words, guard your expression, anticipate conflict. Stress responses activate. The body prepares for threat, even when the threat is merely social discomfort. Cognitive resources deplete in managing the difficulty of the interaction. You work hard merely to keep peace or maintain composure. Again, real phenomena. But no fluid flows from you to them. The person who thinks clearly about this sees more accurately. Instead of vaguely seeking high-energy people or avoiding energy vampires, Almost as though selecting for some invisible fluid content, they ask precise questions. What about this person's company engages my interest? What about that person's company triggers my defensiveness? Which specific dynamics invigorate me, and which exhaust me? These questions lead to actionable understanding. The vague notion of energy exchange leads only to vague notions about people. The same clarity benefits those who work with machines and materials. An engineer who understands that energy storage describes configuration rather than containment asks better questions about the devices he designs. What arrangement maintains this gradient? A water reservoir maintains height above a turbine. The stored energy is the configuration of water above wheel, ready to fall when released. What forces constrain this stress? A compressed spring maintains coils forced closer than equilibrium. The stored energy is the configuration of metal under tension, ready to expand when constraint is removed. What positions enable this release? A raised weight maintains elevation above ground. The stored energy is the configuration of mass above surface, ready to accelerate downward when support is withdrawn. The engineer who thinks in configurations and forces understands his machines. The engineer who imagines filling and draining invisible fluid containers may succeed by rote calculation, but lacks the insight that produces genuine innovation. Here is an exercise that sharpens this perception. For one day, whenever you use or hear energy language, translate it into specifics. This coffee gives me energy becomes the warmth and bitterness of this drink please me. And perhaps the stimulant affects my alertness. That meeting drained my energy becomes that interaction required vigilance and self-monitoring. I emerge tense and mentally fatigued. I need to recharge becomes I need rest, solitude, pleasant activity, or perhaps simply food and water. The exercise reveals how the energy metaphor obscures more than it illuminates. Specificity serves better than summary when action is required. It is manifest that this clarity extends beyond energy to every domain where we mistake representation for reality. The map territory distinction ramifies through all human understanding. Those who mistake accounting for substance in energy often make similar errors elsewhere. They confuse money with value, imagining that because their accounts show wealth, they possess something real. Forgetting that accounts represent actual goods and services. They confuse reputation with capability, imagining that because they are called skilled, they possess skill, forgetting that reputation represents actual performance. They confuse plans with outcomes, imagining that because they have projected success, success will arrive, forgetting that projections represent actual effort in actual conditions. In every case, the confusion is the same, mistaking the map for the territory, the ledger for the gold, the calculation for the thing calculated. And in every case, the remedy is the same. Return to the phenomena. What actually exists? What actually occurs? What specific conditions require what specific attention? The energy inquiry trains a transferable skill. It teaches the most valuable habit of mind, demanding correspondence between our representations and reality, between what we say and what we mean, between how we think and how things are. This is not pedantry. This is clarity, and clarity serves every purpose better than confusion. Before, energy language describes real processes. Low energy means a depleted reservoir. After, energy language summarizes specific conditions exist underneath. Clear thinking requires penetrating the summary to the specifics. We have moved from illusion through principle to practical application. But the deepest question remains. What does this entire inquiry reveal about the relationship between our calculations and reality itself? We have journeyed far. The phantom substance has dissolved. The actual mechanisms of nature stand revealed. And the foundation of conservation, temporal symmetry, has been laid bare. The practical benefits of clear thinking have been demonstrated. Now we must face the deepest question, the one that has lurked beneath our entire inquiry. What is the relationship between mathematics and reality? Our energy calculations work with remarkable precision. Equations predict phenomena to extraordinary accuracy. The conservation laws hold without exception. The mathematics of motion captures nature's operations so perfectly that we can predict eclipses centuries in advance, calculate trajectories to distant points with unfailing accuracy, design machines whose behavior matches our calculations exactly. Why does mathematics work so well? Some have answered, because mathematics is reality. The universe at bottom is mathematical structure. Low energy is not merely calculated, it is calculation. Physical existence reduces to abstract relationship. The equations are not descriptions of nature, they are nature itself. This view has seductive appeal. If mathematics perfectly captures reality, perhaps mathematics perfectly constitutes reality. The success of our equations would then be no mystery at all. Our mathematics would simply be recognizing itself in the mirror. But our inquiry counsels caution. If energy, our most fundamental calculated quantity, turns out to be accounting rather than substance, perhaps we should not be so quick to identify all mathematical objects with physical existence. Perhaps mathematics describes reality without being reality. Perhaps the map is not the territory. Consider the map of London. It captures genuine features of the city's geography. No streets that intersect on paper intersect in reality. Distances on the map correspond to actual distances. A traveller who follows the map finds his way. The correspondence is so faithful that navigation succeeds. Yet no one lives on the paper. The ink is not the pavement. The drawn lines are not the actual roads. The map represents London with extraordinary fidelity, but the map is not London. It exists in a different mode, as representation rather than thing, as description rather than described. Our mathematical physics may be similar. The equations capture genuine patterns in nature, patterns that exist independently of our equations. The correspondence is so faithful that prediction succeeds. But the mathematical objects in our equations may not be what exists. They may describe what exists. Our energy conservation may reflect real regularities in how matter behaves, while the quantity called energy remains purely representational, a feature of our description rather than a component of the described. It is manifest that we must distinguish two claims that are often confused. The universe operates according to mathematical regularities. The universe is mathematical structure. The first is demonstrated by every successful prediction. Planets move in ellipses, pendulums swing with predictable period, falling stones accelerate at constant rate. These regularities exist. Our mathematics captures them. The second is philosophical speculation. That our descriptions work does not prove that reality is description. That our maps correspond does not prove that territory is map. Our inquiry supports the first claim without licensing the second. We predict eclipses centuries in advance with remarkable precision. The calculation is marks on paper. The eclipse is the moon's shadow crossing the earth. The calculation works because it tracks real relationships, the geometries of Earth, Moon, and Sun. But the calculation is not the eclipse. The eclipse would occur without our calculation. Our calculation succeeds by accurately representing what would occur regardless. The phenomena are primary. The mathematics is secondary. The mathematics describes the phenomena. It does not constitute them. This is not a diminishment of mathematics. It is a clarification of what mathematics achieves. Now notice how easily we slide from the equations work to reality is the equations. This slide occurs in energy discourse. Everything is energy. And in broader philosophy, the universe is a mathematical object. The slide confuses representation with represented, map with territory, ledger with gold. The error of mathematical Platonism, believing that because mathematics describes nature perfectly, mathematical objects must be what exists, commits the same category error as energy substantialism. Both mistake our successful representations for the reality represented. The correction is the same in both cases: humility before reality. We know much about how nature behaves. Our mathematics captures behavior with extraordinary precision. But what nature ultimately is, the intrinsic character of the reality that behaves according to our equations, remains a different question. Wisdom distinguishes what is demonstrated from what is conjectured. We have demonstrated that nature operates mathematically, that patterns exist, that regularities hold, that calculations succeed. We have not demonstrated that nature is mathematics, that physical existence reduces to abstract structure, that the universe is made of equations. The first is knowledge, the second is speculation. And here is the wonder that proper humility restores. When we cease identifying our descriptions with reality, we can marvel afresh at the correspondence between them. How remarkable that mathematics captures nature's regularities. How extraordinary that symbols on paper predict the motions of planets, the fall of stones, the flow of waters. How astonishing that creatures like ourselves, bound in flesh, can reach through pure thought to grasp the patterns by which the cosmos operates. This wonder is greater than the false familiarity of everything is mathematics. To say that reality is our equations flatters us too much. It makes understanding automatic rather than achieved. To recognize that our equations describe reality, that they reach across the gap between mind and world to capture something real. This is the genuine marvel. The map is not the territory, but how wondrous that map's work. Before, mathematics reveals what reality fundamentally is: energy, fields, equations all the way down. After, mathematics describes how reality behaves with extraordinary precision. What reality is remains a different question, approached with appropriate humility. We have distinguished description from being, map from territory, representation from represented. What remains is to gather what we have learned into a unified vision and to send you forth with transformed perception. We have travelled far together, from illusion through observation to principle, from principle through application to wisdom. Now we stand at journey's end, and it is time to gather what we have learned. Energy is not a cosmic fluid flowing through all things. It is not a substance that pools in reservoirs and streams through channels. It is not a thing that exists independently of our calculations, waiting to be discovered and measured. It is not the fundamental stuff of which the universe is made. Energy is accounting. It is our bookkeeping system for tracking what forces and configurations accomplish. But it is a number that stays constant because we defined it to stay constant under unchanging natural law. It is the consequence of temporal symmetry, the mathematical reflection of the fact that nature's rules do not change with time. The stone still falls. This has not changed. The pendulum still swings. The fire still burns. The spring still releases. Everything that was true remains true. The phenomena proceed exactly as they always have. The calculations work exactly as they always have. What has changed is understanding. You no longer imagine invisible fluids flowing between invisible containers. You no longer picture potential energy stored in elevated objects like water in tanks. You no longer conceive kinetic energy as a substance residing in moving bodies that transforms into heat when they stop. Instead, you see what actually happens. Forces act upon masses, producing accelerations. Configurations change, releasing or constraining motion. Particles collide, redistributing velocities from ordered to disordered patterns. The laws of nature, unchanging through time, govern all these operations with perfect consistency. And you understand why our energy calculations succeed? Because they were designed to track what temporal symmetry guarantees. This is clarity. This is the dissolution of phantom into precision. Consider a thought experiment that captures everything we have learned. Imagine explaining phenomena to someone who has never heard the concept of energy, a careful observer from some distant land where natural philosophy took a different path. You could describe all phenomena without invoking energy once. The stone falls because gravity pulls it. Its velocity increases because force produces acceleration. It strikes the ground and stops because collision transfers momentum. The impact site warms because ordered motion scatters into random particle vibration. The pendulum swings because gravity pulls the mass downward and the cord constrains it to arc. At the peak, velocity is zero. At the bottom, velocity is maximum. Friction gradually reduces the swing as ordered motion becomes disordered. The fire burns because atoms tightly bound in wood break free and recombine with oxygen in more stable arrangements. The motion constrained in tight bonds spreads as random particle motion. We feel this as heat and see it as flame. You could explain everything. No phenomenon would remain unexplained, or the observer would understand perfectly how things work. Energy would appear only when you introduced bookkeeping. There is a number we can calculate. Half the mass times velocity squared for moving things. Mass times height times gravity for elevated things. And this number stays constant through all changes. The observer would appreciate the convenience, but he would recognize it for what it is, a calculational tool, not a new substance. This thought experiment reveals energy's true nature, indispensable to calculation, invisible to observation, pointing to no object in the world. Nothing that was true is now false. Conservation laws still hold. Engineers still calculate. Machines still work. The accounting remains exactly as precise, exactly as useful, exactly as powerful as it ever was. Only the interpretation has clarified. And this clarity is itself valuable. Those who see energy as substance think confusedly about fatigue, about relationships, about machines, about nature itself. Those who see energy as accounting think clearly. They ask, what actually happens, and receive actual answers. They identify specific conditions and address them specifically. They distinguish the map from the territory and navigate both with skill. This skill transfers the ability to separate representation from reality, calculation from substance, description from described. This capacity serves in every domain where humans think and act. When you hear low energy, you will now ask, which specific conditions? When you encounter energy storage, you will ask, what configuration maintains what forces? When you read that everything is energy, you will recognize the category error, the map mistaken for territory. This is the transformation our inquiry has wrought. Before, energy is the fundamental stuff of the universe. transforming eternally between forms the invisible substance underlying all phenomena. After, energy is our way of thinking about the universe, a bookkeeping tool of extraordinary power, tracking the consequences of unchanging natural law. The universe is matter and motion, force and field, configuration and change. Our calculations succeed by faithfully representing what exists, but what we calculate is not what exists, and wisdom lies in keeping clear which is which. There is an ocean of truth that lies undiscovered before us. The little we have found, a pebble here, a shell there, suffices to show that more awaits than we can presently imagine. We have glimpsed the vastness, the temporal symmetry that underlies conservation, the configurations that underlie storage, the redistributions that underlie transformation. But beyond what we have glimpsed lies infinitely more. We err not in calculating, but in mistaking our calculations for what they track. We err not in abstracting, but in forgetting we have abstracted. The map is not the territory. The ledger is not the gold. The calculation is not the world. And yet, how wondrous that maps work, that ledgers balance, that calculations succeed. This is the gift. Nature permits understanding, not complete understanding. The ocean stretches infinite, and we play on the shore. Not final understanding. Each answer reveals deeper questions, and each pebble suggests vaster beaches. But genuine understanding nonetheless. Understanding that captures real patterns. Understanding that enables prediction, design, action. Understanding that reaches across the gap between mind and world to grasp something true. That such understanding is possible at all is the deepest marvel. That creatures made of matter can comprehend the laws by which matter moves. That minds evolved on one small world can calculate the motions of distant planets. That symbols scratched on paper can predict phenomena centuries before they occur. The correspondence between mathematics and reality is not explained by declaring them identical. It is honored by recognizing it as correspondence. Two different things that somehow match. Description that somehow captures described. A map that somehow guides through territory. This humility before the mystery does not diminish understanding. It properly frames it. We know more than we might have dared hope, and far less than we might have imagined. We grasp the patterns and remain ignorant of what ultimately patterns. And so we continue. We observe phenomena with fresh eyes, seeing matter and motion where we once saw phantom substance. We calculate with appropriate understanding, recognizing our numbers as tracking rather than constituting. We ask, what actually happens, and attend to actual answers. Go now and observe. Watch a candle burn. Trace what actually happens. Wax vaporizes. Oxygen combines. Light and heat emerge as products of reconfiguration. Watch water fall. Trace the acceleration, the impact, the splash. Watch a pendulum swing. Trace the arc, the speed. Observe the gradual diminishment as friction scatters ordered motion into random vibration. Describe without invoking energy. You will find the description complete. Then appreciate what energy adds. A calculational tool of magnificent power, summarizing in one number what the detailed description reveals. Appreciate the tool without mistaking it for the workpiece. The phenomena await your inquiry. The principles reveal themselves to those who look with care, and the ocean of truth stretches infinite before you, patient as it has always been, ready to yield its secrets to those humble enough to ask.